Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss some more 3D figures, that is pyramid, prism, frustum and some more. Friends, we'll be deriving the formula for their surface area, their curved surface area, their volume and all that, right? So let's begin this session. Now, here you can see this is an Egyptian pyramid. The base is square or sometimes it may be rectangle also, and the faces are, all of them are triangles, right? And this is a frustum. This is a frustum of a right circular cone. That means from an entire cone, the top portion is cut, and after that we get the frustum. Similarly, this is an hexagonal pyramid. Okay. Apart from that, we have triangular prism, rectangular prism, cube, pentagonal prism, hexagonal prism, right? And now we try to derive the formula for all of them, right? For their surface area, for their volume and all that. Okay. Now before we move further, I would like to share an interesting thing with you. So there is a relationship among edges, vertices and faces of 3D figures, all of 3D figures, right? Now what exactly the relationship is, just let's see carefully. See, these are known as vertices, right? These flat surfaces are known as faces of the figures, and these lines are actually edges of these 3D figures, right? Here we can see the same thing. These are edges, these are vertices over here, these are vertices, these are so this faces, and these lines are edges of this hexagonal prism, right? Now what that relationship is, that's given by Euler's formula, that is number of faces plus number of vertices is equal to number of edges plus 2, right? So that is a formula by which you can calculate, if two things are given, the third can be calculated easily, right? Let's verify this by taking this cube. See, number of faces will be 6. Vertices will be 8. 1, 2, 3, 4, 5, 6, 7 and 8. Edges will be 1, 2, this 3, 4, then 4 at the bottom side and 4 at the top side. So 4 into 3, 12 and then plus 2, right? So faces plus vertices is equal to edges plus 2. Right? So if anything is unknown, you can find it by putting the remaining 2 in this formula, right? The same can be verified for others also. Suppose we have this triangular prism. Here vertices will be, faces will be 1, 2, 3, 4 and bottom, that is 5. Vertices will be 1, 2, 3, 4, 5, 6. Edges will be 1, 2, 3, 4, 3 this side, 3 that side, 6, then 7, 8 and 9. So that is 9 plus 2. So 5 and 6, 11 and 9 plus 2, 11. Right? So this formula is useful for finding out the third thing, the third, we can see the unknown quantity among faces, vertices and edges. Okay. Now friends, let's discuss each and every shape one by one. Here first of all I am taking a pyramid. So this is the base of the pyramid, this, right? Now this base may be square, base may be rectangular, right? So what will be the area of the base? That is this into this, that is breadth into length, right? If it is square, then it will be length square. If it is rectangle, then it is length into breadth, right? And this is the height from the top point to the midpoint of this base. This is actually height. Now these are triangular surfaces. If it is this square or rectangle, then there will be 4 faces over here, right? 1, 2, 3 and 4, right? So, and all of them may or may not be equilateral or isosceles triangle, right? It's not necessary that all of them will be equilateral triangle. They may be isosceles also, right? And see over here, there is a different pyramid. Here, the base of the pyramid is actually triangular, right? If the base is triangular, then there will be three faces and all of them will also be triangular, may or may not be equilateral, right? So in this case, area will be calculated, the surface area will be calculated same as we calculate the area of a triangle, right? If it is an equilateral triangle, we'll be using the formula for equilateral triangle area. If it is an isosceles triangle, so we need to know, we need to have the dimensions of the three sides, then we can calculate the area of each and every surface, right? Now, if we open up this pyramid, it will look like this. Since this is a square, all these four are triangles, right? Maybe this is different and these lengths are different, but at least it will be an isosceles triangle. May or may not be equilateral, but definitely an isosceles triangle. Otherwise, the points will not join at one point, right? So this is the open up figure for this pyramid. This is a pyramid that is an Egyptian pyramid that I can show you over here. This is having the rectangular base and the faces are triangular. This is triangular pyramid. The base is triangle and there are three faces. In this case, there are four faces. Okay. So let's calculate the total surface area in this case. See, the base area will be length into breadth. If it is a square, it will be length square. That is the base area. Plus, there are four triangles. So, area of four triangles, right? Now, if it is an equilateral triangle, area of each triangle will be root 3 by 4 side square. If it is not an equilateral triangle, then we need to use the other method to find out the area of the triangle that I have already discussed in our basic sessions of geometry. Okay, so any of them can be used. Okay, and in this case, if once again, if the base is an equilateral triangle, then there will be four equilateral triangles. So root 3 by 4 side square into 4. That will be the total surface area. But you need to be clear with each and every surface. How to find out the area of each and every surface, that should be clear, right? Because sometimes the entire surface area is asked and sometimes the curved surface area is asked. Curved surface is known to be this surface, that is the top surfaces. Okay. Now let's see what will be the volume of this pyramid. See, volume for every figure is actually base area into height, right? If the figure is straight, that means if it is a cylinder or maybe it is a cube or something like that. But in this case, this actually the figure has slant height, right? In this case, what will happen? It will be 1/3 of the base area into height. The volume of pyramid will be 1/3 of the base area into height, because this is not the straight one, right? Suppose we have the cylinder like this. So in this case, the volume will be base area into height, that is pi r square, that is base area of the circular surface into height, right? But if we talk about cone, right, so it is pi r square h by 3, that is 1/3 of the base area into height. The same is the case with this pyramid. 1/3 of the base area into height, that will be the volume of this pyramid. Okay. Similarly, we can find out the surface area and volume of other 3D figures as well, right? So here, suppose we take this rectangular prism. The base area is rectangle. So the base area into height, that is L into B into H. That will be the volume of this rectangular prism. It is nothing else but a cuboid. Similarly, that is a cube. So that's base area, that is L square into height, because it is a cube. So the third dimension will also be same. So it's L cube, right? So this is what the volume of this cube, and this is what the volume of cuboid, right? Now, if at all we wish to find out the area, surface area, then easily we can calculate. This is length into breadth. Two surfaces are there for length and breadth, the top and the bottom, right? Similarly, this surface, this is length into height, this and this. So that's length into height. Then this, the last one, that is breadth into, this height into breadth. Okay, so once again two surfaces will be like this. This is this and this. Okay, so two surfaces length into height, two surfaces breadth into height, and two surfaces length into breadth, and this is the volume. Similarly, if we find out the surface area of this triangular prism, now this is a rectangular shape. This is also a rectangular shape. This is triangular shape. This is a triangular shape, and the base is maybe a square or a rectangle, whatever, right? So the total surface area will be given by the area of the base, area of this rectangle, plus area of these two triangles. Okay, so that will be the area of the, and apart from that we must be knowing whether these triangles are equilateral or isosceles. Okay. Similarly, it is hexagonal prism. So base area will be this area of this regular hexagon. So area of regular hexagon is actually combination of 6 equilateral triangles. So root 3 by 4 side square, that is the area of one triangle, and that is 6 triangles. So this is the base area into height. Height means this length. That will be the volume of this hexagonal prism. So this is the volume. And if we talk about the total surface area, the total surface area will be area of this hexagon, area of this hexagon. So 2 area of hexagon plus there are 6 rectangles like this. So height into the side of this hexagon, that will be the area of each rectangle, right? So suppose height of this is h, and this side of this is say s, and like this there will be 6 rectangles. So you can calculate the total surface area of this hexagonal prism. Similarly, for pentagon prism, the base area, that will be the area of this pentagon into height, that will be the volume, and the base area, this area, and 5 rectangles will be there, and they will give you the total surface area of this pentagonal prism. Okay, so all these are very easy. The only funda that works over here is the base area into height, that is volume. If it is a slant figure, then the volume will be 1/3 of base area into height. If it is a straight figure, then it will be base area into height. That's it. Now we discuss the case of frustum in detail. Now friends, here I have given various pictures of frustum of a right circular cone. See here, this is the complete cone, and if it is cut horizontally, that means horizontal to the base, then this top portion is again a smaller cone, and the remaining portion, that the bottom portion, is actually frustum, right? So this is frustum and this is smaller cone. So this is the frustum, right? You can see the various figures, images over here. This, right? Now surely, a frustum of a right circular cone has 2 unequal flat circular surfaces and a curved surface, right? This is a circular surface, this is a circular surface, but they are unequal, and this, the dark green color, that is the curved surface, right? Now what will be the height from this center point to this center point? This is the height of the frustum. Okay, and from this point to this point, that is actually slant height, that I have shown over here. This is the slant height, and from this point to this point, that means center of this circle to center of this circle, that is the height of the frustum, right? So, and here you can see this is the radius of this bigger circle, and this is the radius of this smaller circle, that is R1, and this is R2, right? Now let's see, how do we calculate the surface area, the total surface area, the curved surface area, and the volume of a frustum of a right circular cone. Okay. Now we have this frustum. Here, these two circular surfaces, the radius of this circular surface is R1, this is R2, that the radius of the smaller circular surface, and distance between these 2 points, that is center of circles, is h, that is height of the frustum, right? And we assume that the slant height from this point to this point, the slant height of the frustum is L, right? Now what we do, we complete this figure by making it to a cone, by completing it to a cone. So it's something like this. Okay. Now let's complete this figure. Here I suppose this point to be A, this point to be A dash, this point to be B, this point to be B dash, and this point is suppose V. I assume the center of the circle to be O, and here it is O dash. Now from this point to this point, that is height of this cone, this frustum. So that's also H. Now you can see this length is R2, this complete length is R1. From this point to this point it is R2, right? So this length, that is from this point to this point, this length will be R1 minus R2, this total length minus this length, that is R1 minus R2, that is this length. Okay, I assume this point to be suppose L. Now friends, the important thing over here is this triangle VO dash B dash and VOB, both of them are similar to each other, right? Because this line is parallel to this line, right? So VO dash B dash is similar to VOB. VO dash B dash is similar to triangle VOB, right? If the two triangles are similar, obviously their sides will be in the ratio. So the side of this triangle is VO dash by side of this triangle is VO is equal to R2 by R1, and the third side is this total length. I assume the total length VB to be L1, this total length. So for this triangle, this length will be total length minus this length, right? Now B dash is L, that is slant height of this frustum. So this length will be total length minus this length, that is L1 minus L, and the total length is L1, right? So the sides are in proportion. Similarly, I assume VO, that is the total height of this cone, to be H1, right? So VO dash will be VO minus O dash O, right? So VO is H1 minus O dash O is H by VO is H1, right? So this is the relation that we have got. So when you are having a problem based on frustum, instead of mugging up the formula, what you can do, you can put up this triangle similar to this triangle. That means you can put up the sides in ratio, right? After that, whatever the information is given to you, just put it up and find out the remaining quantities, that is R1, R2, whatever is the left. Okay. So for that, you don't need any formula to mug up, right? Now we calculate the volume of the frustum of the cone and the surface area, that is lateral surface area and the total surface area of this frustum, right? Now volume of cone will be what? Volume of this frustum will be what? Volume of VAB minus volume of VA dash B dash, right? So I write volume required, that is volume of frustum, will be equal to volume of this cone VAB minus volume of cone VA dash B dash. Right? Now you must be knowing the volume of the cone, that is 1 upon 3 pi r square h. So I take common as 1 upon 3 pi r square. That means for this VAB, r square will be r1 square and h will be the complete height VO, that is h1, minus here for this it is r2 square and the height will be this height, that is the total height minus this height, that is h1 minus h. So if you simplify it, it will be 1 upon 3 pi r1 square h1 minus r2 square h1 minus r2, plus r2 square h1. Sorry, this is h1 minus h only. Okay, so that is 1 upon 3 pi, so that is h1 r1 square minus r2 square and plus r2 square h. Right? Now it depends, whatever the values are given to you, according to that you need to proceed. So I will not tell you how to substitute the value from one relation to other relation, that you can do on your own. Right? Depends upon the quantities which are given in the question. Okay. So this is precisely the volume of the cone and how to volume of this frustum. So how would you learn that? The volume of the entire cone minus volume of the smaller cone. That's it. That is the volume of the frustum. Volume of the cone is, that's very simple, 1 upon 3 pi r square h, and volume is the smaller cone, whatever the quantities are given, according to that 1 upon 3 pi r square h. Right? So precisely r and h are unknown for both of them, right, for the smaller cone and for the bigger cone. So if you have that, you can find out the volume of this frustum. So that's pretty simple, no need to mug up any formula. Now let's find out the surface area of this frustum. Now suppose we have to find out the this curved surface area of this frustum. Again, you can very well see from this entire cone, the curved surface area of a cone is actually pi rl. So for this entire cone, it will be pi r1 and the total length is l1. This is the curved surface area of this bigger cone, right? From that, if you subtract the curved surface area of this smaller cone, that means this complete area, if it is deducted, then we'll be getting the curved surface area of this frustum. So that is pi, radius is r2 and height is the complete height minus this height. So that is h1 minus h. So this is what? I'm sorry. It's a slant height. So that's L1 minus L. So this is what the curved surface area of this frustum. Now suppose you have to find out the total surface area. That means this curved surface that we have already found out plus area of the smaller circle, that is pi r2 square, plus area of this bigger circle, that is pi r1 square, right? So precisely you don't have to learn even a single formula to find out the volume or area or maybe curved surface area of a frustum, right? If you are logically clear that both the triangles are similar to each other, just put up that condition and you must be knowing the basic formula of cone, then you can find out each and every relation related to frustum, right? I hope you are clear. Now friends, I take a practical example. I just take a question based on where we have to find out the volume of a frustum. So the question given is, draw a frustum over here, just wait for a moment. Okay, here it is given that the radius of the bigger circle is 28, radius of this smaller circle is 7 and height of this frustum is 45, right? As I already told you that you no need to mug up the formula when you have to find out the volume of this frustum. Now what you can do, you can, even you don't have to do in fact, but for explanation, I'm just doing it. I just complete it into a cone. Now this is 1/4 of this. That means this length should be, or I'm sorry, this length, because this triangle is similar to this bigger triangle. That means this length should be 1/4 of the total length, right? That means this must be, the ratio of this and this must be 1:3. Then only this length will be 1/4 of the total. If it is 45, it has to be 15, right? So you got this length. That means you got height and radius of the smaller cone and height of and radius of the bigger cone, right? Now what you have to do to find out the area, volume of this frustum, you find out the volume of the entire cone and then deduct the volume of the smaller cone. So that is 1/3 pi. Now r square h, right? So r square is 28 into 28 into h is what? 60 minus r square h. So 7 into 7 into h is what? 15, right? Now we just solve it simply. You can take common. 7 into 7 into 15 can be taken as common. So that is 4 into 4 into 4 minus 1. So that is 64 minus 1, or I can say 63, 621 and into 3. Just multiply all these figures and you'll be able to get the volume of this frustum, right? So precisely you don't need any formula to find out the volume of the frustum. Similarly, you can even find out the curved surface area and the total surface area of this frustum, right? Because this length will also be in the ratio. Now this is 15, 7. Obviously, these three will be in Pythagorean triplets. So you can find out this. So that's 15 square plus 7 square. So that is 225 plus 49. Will be an odd figure because in this particular question it was not asked to find out the curved surface area. So don't mind, but this way you can find out the curved surface area of this frustum. Okay. Now in this question, the slant height of the frustum is given as 4. So that means this length is 4 and the perimeter of circular bases are 18 centimeter and 6 centimeter. That means 2 pi r1 is 18 and 2 pi r2 is 6. Okay. So precisely r1 is to r2 is 18 by 6, or we can say 3:1. Now I complete this. Now r1 is to r2 is 3:1. So I assume this to be 3k, then this must be k, right? Now this length is 1/3 of this. That means this length will also be 1/3 of the total length, right? This length is 1/3 of this. So this length, that is the slant height of the smaller cone, will also be 1/3 of the total cone, the bigger cone. That means the ratio between this length and this length must be 1:2, right? So if it is 4, it has to be 2. Now 2 is 1/3 of the total length, that is 6. Okay, so that is the slant height of this smaller cone. This is the slant height, that is 6, the slant height of the bigger cone. Now we have to find out this curved surface area of this frustum. So curved surface area of the bigger cone, that is pi into r, that is 3k into L. L is what? 6. Minus curved surface area of the smaller cone, that is pi k into 2. So pi into k is common and it is 18 minus 2, that is 16. Okay. Or precisely what we can do is pi into, instead of this radius we can put up the value of r1, that is 18 by 2 pi, and this is 6 minus this is pi, this is 6 by pi, 6 by 2 pi into 2. Okay. So that is 54 minus 6, 48 units. Whatever, if it is centimeter, then it is centimeter square. Right? So without using any formula, we just have put up the concept of similar triangles over here, and we have calculated the curved surface area and volume, both of them for a frustum. Right? If you are asked about the total surface area, then R1 and R2 are already there. Just add up pi R1 square plus pi R2 square. You will be getting the total surface area of this frustum. Right? You just have to add both the quantities into this 48. That is the curved surface area. Right? You can simplify this calculation by taking the things as common, and you can eliminate the step. Actually, it is not at all necessary. It's just pi R1 L1 minus pi R2 L2. Right? That's it. That is the curved surface area of the bigger cone minus curved surface area of the smaller cone. Right? So friends, in the next session, I'll be taking some more problems based on 3D figures like pyramid, frustum, and other 3D figures, maybe hexagonal pyramid. So I'll see you in the next session once again. Bye-bye. Do revise this session before you come for the next one. Bye-bye.